We were trying to deal with memory leak
Right.
completely.
There's a memory. Okay, well there's which tests failed? 120, 130, 128, 128 failed now. Let's open that one. So the problem here is so we're running debug version of Python with x showref count, and this shows 526 references leaked. Do you have any idea what that means?
A very vague idea. So every time a symbol is used, its reference count is increased, and every time you stop using that symbol, you should decrease the reference count.
Right.
And there's a lot of things about it, and cyclic possibilities, and garbage collecting, and a lot of things on top of that. But I don't know which one is relevant for now to understand this. 526 looks like quite a huge number.
Well,
Is it normal?
yeah, it's a normal leak. So instead of symbols, it's about Python objects.
Okay.
So each Python object has a reference count. When the reference count goes to 0, the object is not used anymore and it's deallocated. And when it's part of a cycle, the garbage collector decreases all the reference counts to 0 by looking at what objects reference each other, and that's done with these visit functions, the traverse functions, right? So Python calls this to see what objects are reachable from the module in this case. So directly reachable objects are all of the types, and when it sees like a cluster of objects that only reference each other, then it clears the objects. So it will so clear means decrease the reference count and set the pointer to 0 or to null. And this, if everything works correctly, this will decrease the reference count to 0, at least of something, and that means the object is deallocated. If this doesn't decrease the reference count to 0, then the object is left reachable and leaks. Right? Nothing can use it because nothing has a reference to it, but it stays in memory. So, what is the problem? The problem is this: we intentionally leak a reference to type, once per type per process. Well, it's probably that. See this PyModule add object. Let's look at the documentation for that. So PyModule add object steals a reference to value. So it's it's similar to PyModule add object ref, which somewhere here, which will add this object to this module under this name. Right?
Mm-hmm.
Has some convenience, but that's about it. And this works like a normal Python function, which means the value is borrowed. If you call it, you need to have a reference to this value, and you still have a reference to the value afterwards. Right. So this is a new function, and it works nicely. AddObject is the old function. It's been soft deprecated in 3.13, and it's been there since Python 2. And it doesn't work nicely, and that's why it was replaced. So the problem here is it steals a reference to value on success. So when you call this, you have a reference to the value, and after you call it, you don't. So the ownership of the reference is transferred to the object. Does that make sense?
Yes, it does.
Right. But only on success. If this fails, then you still have the reference afterwards, which is weird. And apparently the person who added this didn't add this detail to the documentation right away. If they did, they'd change the implementation. But that's where we are. We're using the old function because it's available in current Python versions. So this means if this fails, we still have a reference to the type, and we need to do a decref.
Yeah.
Right? So let's count references. So this is our helper, init and add type, which is called down below with a pointer somewhere in the module state. Right? So it will set this pointer for us.
Yes.
Right? And the module state will own this reference. By own, we mean that it is responsible for freeing it, or for decrementing the reference count. That it does in here. Right? So that's what ownership means. We need to get rid of something. So what does init and add type do? It calls PyType from module and spec, which behaves normally, which means it takes its arguments as borrowed references. Right? So we need to own a reference to this module, and this function borrows that reference for the duration of the call. It can do anything with it, and we, as init and add type, our own code, is responsible for keeping the reference alive while this function is executing, while it's being called. Right? The same happens here. Whoever calls init and add type is responsible for keeping M alive while this code is being executed. Right? So it works normally. The spec works the same way. There's null here. So that's for arguments. Now for return values, the normal behavior is that the caller owns a new reference to the return value. Right? So PyType from module and spec is a well-behaved function that creates a new reference to a new object. Because it's a new object, it will probably be the only reference, and it gives that reference to us, and that means we now own it and we need to take care of it. Right? What do we do with that reference? We set this pointer to that, right? Which means we write it in this location, and the module state is now taking care of it. So that, so far so good. So right now, there's one reference to the type, and it belongs to the module state.
Module state, yes.
Right. So what do we do then? We increase the reference count, which means we now have well, there's one reference to it in the module state, and now we have one extra reference that we need to take care of. Right? As the comment says, that's not good. Next up, we call PyModule add object,
steals the reference,
which steals the reference exactly.
but only one.
Yes, that steals the reference we made here. Right. So that's good. So if this succeeds, there is one reference and it's in the module state, so that's good. When this fails, it doesn't steal, so we do this decref, and we're good. So PyModule add object internally transfers this type. Well, if it succeeds, it transfers this type's ownership to the module or the module dictionary. Well, that's good. So this should be there. So let's do this for the comments. So here we should well, the module state should own a reference to the type, and another reference is handled by the PyModule add object. So that looks good. And that also means the reference leak is somewhere else. And I have no idea where. Let me check the RPM tests directory. Is that? Oh, I guess I should.
They will all fail, right? Because of the additional output.
Oh, it shows all the tests, not only the failing ones. No, this one failed.
No, the list is not sorted. The list of the tests.
Oh, this list is what? Why? Okay. Never mind.
This is a test that tests import.
Right, it imports RPM and that's about it, right? And it leaks 519 references. So let's do one thing. Let's see. How do I find this test? In this RPM Python add. Is this basic RPM?
No, I think it's import.
Import, this one, the first one.
Import, yes.
Right. And all the tests import something, right?
It's part of the boilerplate, the RPM PyTest, which is somewhere at local or local.
In? No. Local at? RPM PyTest. RPM PyCheck. RPM PyRun.
Yes, and here it imports since it's.
Right, here it imports RPM. Okay. So if we don't import RPM and don't do anything at all, how will the test output change? I guess I need to get rid of this print as well, right? Zero refs, zero blocks. Okay. So that's the baseline without importing RPM. Where local dot, I don't need this one. Need this, I do need that one. So local at. So let's do import underscore RPM. What does that do?
Should probably be RPM dot.
Oh, RPM dot. Oh, it's a submodule, so I need to import RPM dot underscore RPM, right? Or just import RPM, all of it. Okay, and that's the 515. Okay, so let's do this. Let's just not do anything here. Init module, return 0. Success, right? So RPM, of course, tries to import transaction core, which it fails to do. But this exceptions are still good, right? In terms of references, exceptions should still be handled correctly. So far so good. What is this RPM read config files? I guess that's an RPM function and it doesn't really do anything with the Python API, right? So there's D, PyModule get dict. What does PyModule get dict do? Return value borrowed reference, right? So this has a note in the documentation. The reference is borrowed from the module in this case. I mean, it should say where it's being borrowed from, but sometimes it just doesn't do that. So we don't own this reference. We can just use it until we can't use it anymore. Which is until somebody changes the dictionary of this module and throws away the old one, which hopefully nobody will do while we still need it, right? Well, that's why this is not very good API. So this should still work well. Alright, 0 refs. Okay, let's go on. There is some kind of Python version check. I think we went through that. Let's see if that works, right? No reference leak there. there's PyModule get state. I would be very surprised if that leaked. Right?
No.
So normally I'd put the return 0 somewhere in the middle and do a bisection, but linear search is probably better here. So what do we do here? PyRPM error. We do PyErr new exception, right? Which I think is good modern API. Returns a new reference and borrows its arguments, like the base and the dict. So now we hold a reference to the PyRPM error. If I return here, that reference will be assigned to PyRPM error, which means it will get cleared at the end. Hopefully. Nope. One reference is left, which is weird. Which is weird. Why would it be just one reference? So the little problem with this mode of operation, the xShowRef count, is that it cannot tell you what reference is the problem, because there's just a number that goes up and down as you do the increfs and decrefs, and it doesn't track them individually. So what's happening here? We're creating an exception, putting it in PyRPM error, and that's it. Does it get ever cleared?
It does.
Let's make sure.
Oh.
Whoa, whoa, what is happening here?
Is it guaranteed that?
Yeah, I see the problem. It's cleared from this and then cleared from the null pointer. Because we have RPM module clear and we also have RPM module free, which calls the clear. So far so good. What is the problem with PyRPM error then? New exception, we put it in the module state. Then it's used in PyErr set string all over the place. Well, there is one very esoteric thing that might be happening, which is we're not building with the debug version of the headers and the reference counting, like the bookkeeping for the show ref count is being thrown off by that. I would hope that's not possible. Let's try this. So
can I ask, just before we go further, in this GG output in your terminal, there is RPM system by likely one of the late.
This one?
No. Third from the last. There's PyObject asterisk p RPM error. I'm surprised to see PyRPM error without our like mod state context. What's happening here?
Yeah, that is weird. By RPM system. Py. Huh. Where's this Python RPM system Py? Oh, that's the definition. That's part of the module state.
Okay. That makes sense.
Yeah, let's see it in context. Okay, so let's do this. Let's make an exception. And then immediately clear it. And that leaks a reference. Okay. So that means the show ref count is lying to us. Let's see what we can do about that. Instead of pyclear, we can use pydecref. It's a function version of the thing you usually use, which is either xdecref or plain decref. The difference here is you can pass the null pointer to this one, so it's safer. But it's implemented as a macro, a C macro, which does which is fast. Right, this is an extremely fast operation if it doesn't actually need to delete the object. It just decreases a number, right? And the overhead of calling a C function from a different module is much bigger than decrementing a single number in memory, right? That's why this is implemented as a macro, which means the implementation when it's compiled will live in our extension module, right? And in the debug version, for the show ref count, for the D, it has to decrease two numbers. It has to decrease the reference count of the object, and it also has to decrease the reference count, like the global counter, global debug counter, right here, right? And if our macro is not compiled for the debug version, it doesn't do the second thing. So that might be the problem. So if we, instead of pyclear, we do which one was that? Pydecref, a function version. So this means it will actually call into Python, and Python will do the right thing. So it was clear before, so to be the same thing we also have to set it to null. or rather this sets it to null beforehand and so on, but let's do this. It doesn't really matter because we don't ever use the variable again. And there we go.
Mm-hmm.
So, okay. Let's see if that will fix our problem. So instead of pyclear, let's do this. We'll undefine pyclear and define our own version, right? And something like this. Oh, and it cannot be a function, it needs to be a macro. And it will call decref. Is that the right spelling? Yes. So we decref the object and set it to null. Right, that's a macro like this, right? It needs to be a macro because if you pass this to a function, it'll make a copy of the pointer, which means we cannot set it to null. I mean, we'll set the copy to a null. Did I write that correctly? No. Oh, it's not a py object, right? So the problem here is if we go here, it's a PyType object, right? And PyDecref is a function that, unlike a macro, needs a particular type. But we know we can cast it. It's better to put this in parentheses. I think I told you that. Weird thing about macros. We're getting rid of the slashes later. Okay, and that decreased the number of our references a bit. And the problem is all the other decrefs in this entire extension are doing the same thing, right? So this will not help us. Instead, we will need to compile this correctly. And that means looking into the CMake lists. Can we... Do you know what to do with CMake?
No.
Okay. So CMake is some kind of build system that uses its own syntax to do whatever make does, but better. But you need to understand it. Target compile definitions. So apparently this will set PyLimited API to this value. Now I know PyLimited API is preprocessor definition, like with hash define, and if you set this before including python.h, it will limit the API you can use. So another one you could use is PyDebug, I think. With PyDebug, it will define the PyDebug macro. we define PyDebug like this, it might work, might not. So what's the warning? Was that there before? No, probably.
Wow.
Okay, so yeah, somewhere else in the CMake lists there is some logic to find Python. This one. And if I... Oh, this is probably something we'll need to revert. If I could change that logic to point it to the debug install of Python, then that would be great. You know, I'll always compile with the Python you'll be running onto. Yeah.
That must be defined somewhere. It's Python 3.
Can you just do Python 3D? I don't know. No. Oh, it's Python. Python 3 config.cmake. Yeah, find package Python 3 is probably built into Python, into CMake somehow. I don't know.
That may be the case, although a lot of packages bundle their own copy of CMake files, which I have to update on every new Python
Interpreter debug
projects, but I think RPM does not include its own copy.
What? Oh, there's a set Python 3 find ABI. Defines which ABIs should be searched, and you can set PyDebug. Okay. Can you just do that?
No. Wait. There is a double D because we
run. Really?
It.
Oh, yes. Oh, whoa. Where did we?
We put it in
where
this.
Did we put it? Debug hack somewhere. In Clan. All right.
Long line 49.
Oh, nice. Okay. And this is looking good. Okay, so we might want to clear this clearing or this printf, and now all the tests will fail because they have something extra here. Can we change the tests to expect that? Just check.
There is RPM test. Okay, clean now.
So RPM I check 1, 2, 3, 4. What does the test look like? So the argument after the source is the expected output, right? So if this is 2, so can I just put 0 refs for 0 blocks?
Somehow in the wrong place. 29 says minus the
Oh,
same.
this is standard error and this is standard output. Okay. Will number 3 be the thing we're looking for? Oh, that was just a guess. Oh! Oh, I just need to escape this special character, right? How do you escape stuff in M3? Can you do this, or is there a special syntax? No.
About double?
Double, okay.
That's just as wild idea. And
okay, that's the last one after after looking it up. Oh, before looking it up. No. Okay. M for literal bracket. No, I don't want screws. Notes on the right, okay.
AC help string. Wait. What? Stack Overflow. Sometimes you need to double quote as well, like more quotes to the rescue. But the general most voted answer is avoid square brackets wherever possible.
Oh no. That sucks. Okay. Let's avoid square brackets wherever possible. How do we do that? Like, is this... Could you link the Stack Overflow thingy?
Yeah, it's there are at least 4 before being before not using. There is also a change quote thing.
Yeah, that's for quotes.
Use a quadrigraph.
Quadrigraph.
And that one.
Okay. Quadrigraph. So C has trigraphs and digraphs, but quadrigraph. Oh! Now I need to skip the comma somehow.
Okay.
And is there a quadrigraph for a comma?
Not on this page. There is one that expands to nothing.
Can I put square brackets around a comma? Oh! That did it! There's now a difference in an empty line. So
And another empty line.
another empty line. The standard error has one more empty line. That's this one.
Oh,
And now there's a difference in standard output. 599.90.
yeah,
Is
because
there
we
a
have
debugger?
RPM version. We commented the test.
Oh, well, okay, we're getting
Some of
closer.
it actually like succeeded, and that one should also succeed if we uncomment. Yeah.
Oh, nice! And now we need to uncomment all the rest in here, right?
And delete the first import maybe, but that's not important.
All right. Okay. 3 failed tests.
Yeah, one kind of expected as always.
Right. There's archive 1. Okay. 3.
Oh, leaking.
It's leaking a lot. What do you know? Maybe it leaked before. And there's 120. 1. And that leaked one thing. Okay. All right. Perfect. So, what changed? This thing, that thing, that thing, and that thing. I guess that's all good. It's a combination. It's yeah, needs to be combined with the debug hack. Squash this. And Now we're combining the debug hug with this incref, which should be there. But okay, that's good. All right, so let's continue. And so the problem is that test 121, which is testing transaction element metadata, user data, is leaking one lone reference. So I'm pretty sure there are better ways to debug reference leaks, but one is to comment this out and do a binary search. Bar lock is missing, but
where's our out?
This is a diff of the output, so
This
it's
is
missing.
Oh,
It's
no.
missing. It's good. Okay.
Holy.
So this thing is creating a dictionary. This is adding some install. So let's see if that changes stuff.
It doesn't.
Oh, that's good. So then we, for each TS, we set the user data. And that begins leaking. So that's where the leak is. I'll uncomment the printout. So the leak is, wait, when I comment this, what do I get? Okay, I'm having some trouble with my editor lately. Let me split this so I can watch the build test log. Okay, so now it says the user data is none, but no leak. So let's unpack this thing. So this does my data is this, and there's a weird N. Who knows what E is? So this should do the same thing as before. No. Oh, I didn't pass my data to the set user data, right? Battery factor.
Oh.
No.
Wait, what you doing here with my?
I'm reusing the variable, so it's
it's
a bad one in the next iteration of the for loop. Okay, so right, something leaks here. So is it this? Yes.
No.
Yes.
Wait.
So the difference is that the data wasn't set, so we're getting none, but there's no leak.
Yeah, yeah.
So the user data function, or the user data method of E, which is an element of TS, and TS is
Transaction set or something like that.
RPM TS, right? So we have set user data. Well, it's a method called set user data. RPMTE.py. Oh, so the element of RPMTS is transaction element, right?
That's obvious, right?
Oh, yes. RPM.
Just above this.
Yeah. So set user data. Okay.
Ooh.
How to ensure this is a PI object? So it gets RPMT user data from this TE.
Recursively calls itself? No, it's not the same.
It does RPMTE set user data to arg. It encrypts arg and decrypts O. Right. And then it returns noun. Okay. So what this does is there's some STE. So S is the RPMT Python object. The T inside that is the RPM, like the librpm transaction element. Let's call it that. Right? And on this transaction element, you can set user data and you can get user data. And what happens is we're getting the old user data and doing an xdecref on it. So if it was null, nothing happens. If there was already a Python object, it gets decrefed, it gets destroyed. And we're also setting a new object, and because we're setting a new object, we need to encref it so that it's this arg is borrowed, so it's only valid until the end of this function. So in order to give the ownership to this user data, we need to encref it, right? So this is the low-level operation where we're giving the object to RPM itself. And here we're saying RPM now owns the reference. But it owns the reference, which means it needs to destroy the reference at some point. And I'm pretty sure it never does that. Because it would need somehow to watch when not this Python wrapper but this transaction element internally is destroyed, and when that happens, this decref needs to happen, right? So unless RPM itself has some way to call a custom function when the user data is or when the TE is destroyed, or when the user data is destroyed, then we're out of luck. Is there any documentation for this function? Transaction element API. FTP.
Yeah, that's
whatever.
Yeah.
Just show me the information.
That's how you know it's the real one.
I'm running it in a container, right? Everything's safe. RPMT
user data.
set user data. Right, retrieve private user data. I don't see any callbacks. So, this needs an XXX. How to
insurance. Perfect.
It is a transaction element.
Mm-hmm.
What? Okay, is there an RPMTS? Ooh. There's a change callback. Yeah, so this leaks, and I don't see a good way to fix that, so there we go. There we go. So this one we revert. Right, and we're out of time, so there's a bigger leak in archive 1, but that's for next time. Bigger just might mean that more objects are kept alive by one bad reference, or there is a loop or something like that.
This project, I'd like to play with it.
It's my multi-phase, right?
Yeah.
I changed history. Sorry.
The winners run history. That's a good thing.
Right, so see you next week.